Cool. So welcome everyone. That was not a great tonight. Lovely welcome everyone. I would like to make a few announcements before we get to our great speakers. First of all, of course, great thanks to Bol.com, who gave us some really nice food and are giving us this nice place. Now, Maarten, our host, he asked me to ask, he tweeted something on #Docker. He tweeted that we're having a live stream for here for everyone to watch. So if you would all please, if you do tweet, check out that tweet on #Docker and retweet Maarten Dirks, and we'll get as many followers tonight as possible. That's point one. The other thing, which really doesn't have to do with this meetup, although it does a bit, this meetup kind of already feels a bit conference-y-like, seeing so many of you here, so that's really cool. But the real Docker conference in Europe will be 4 and 5 December, and it has been announced officially today. Also, starting today, you can go to europe.dockercon.com. Maybe you can show it in the meantime. Europe.dockercon.
I don't have Wi-Fi here.
Oh, we don't. Oh, okay. So you'll have mobile phones. Europe.dockercon.com. Tickets are being sold from today. If you want to be an early bird, be quick around it, because only the first 100 tickets sold will be early bird. Oh, by the way, that's why I make notes. Great credit to Pini Rechnik for that, because he has been doing a lot of work. He's over there. Stand up, Pini. Then I would like to introduce our speakers, of whom I now know 2 faces, which is enough for before the break, but not enough to know which one of you all have VGA. So if the speakers would please come over for a sec. We have one speaker over here, Wouter. Hi, do you have VGA? So, yeah, okay, so that's HDMI. Speaker number 4, that would be you. You're talking USB. Cool. So then you will be the second speaker, and you can be on this one. So the speakers are Timo Derstappen here. He's giving an introduction into CoreOS. Wouter Deems, he will be after the break then. He's giving an introduction into, well, it's all introductory. He's talking about using Docker for integration tests and continuous integration, and the Maven Docker plugin that he wrote. Also, we have Lennart Katz, adopting Docker at Cloud9, and Marcus van Dijk with Surf, Zara, and Docker. I wish you all a pleasant night, and to you, the first word.
Hi, my name is Timo. I hope it's okay. I don't like the micro as well. I came all the way from Germany just for the delicious food, and yeah, so I have to give a talk. I want to give you some insights, some overview of CoreOS. Who of you has used CoreOS already? Every day? In production? Okay, nice. So my company is in Cologne, and we're building a product on top of CoreOS, and that's why I'm doing lots of stuff with CoreOS right now. And yeah, if you want to have an invite when we are ready, then go to giantswarm.io. So CoreOS is a minimal Linux distribution that has like write the things for running Docker containers and having a cluster of machines to orchestrate those containers on those machines. So it's kind of like the basis for a Google data center-like infrastructure for everybody, right? So usually I give a talk about comparing CoreOS with Kubernetes and Mesos, and I give some overview what you need for orchestration, and the building blocks are configuration management. You need to know which container is running in the runtime. When your cluster is running, you need to know where those containers are running to do service discovery, and to know how many of them are running and how many should be running and how many should be restarted and stuff like that. And you also need a scheduler to do that, because you have like lots of different jobs. You have services running, you have batch jobs, and you have cron jobs running, and you need something that knows where your resources are in the cluster and where to run those jobs, and to learn about those jobs, what resources they consume, like if they need memory, lots of memory, lots of CPU and stuff like that. And that's what CoreOS tries to give you. It's a minimal Gentoo. That's why they came up with the idea that servers should update themselves automatically, and they took that idea from Chrome OS, and Chrome OS as well is built on Gentoo, and they implemented their own Omaha, I think the protocol is called Omaha, update service to do updates automatically. And it's actually downloading your root file system in another subvolume. It's based on Btrfs, and they're switching the rootfs when you reboot the system. And you can also go back to the version before. You can switch back, but you have to reboot for that. CoreOS builds images for all of the platforms out there. So if they're infrastructure as a service or virtualization, you most probably find an image for that. Officially, they have Amazon, Google Cloud, Google Compute Engine, Vagrant, OpenStack, and there are some community contributions. And the other things are systemd, Btrfs, and Docker, and those are not from CoreOS itself, but CoreOS also has their own tools, and they are etcd, which is a key value store that that is for configuration management. So you can store information that a container is running on this host in etcd, and you can read it on another host that where this container is running. So it's a key value store. You can watch keys. You can, of course, write data, read data, stuff like that. And Fleet is built on top of that. And Fleet is the scheduler that decides which job or which container should run on which machine. And this is built on top of the key value store etcd. Locksmith is another tool. I don't have mirroring, so I'm always looking back what I put on the slides. So Locksmith is for the update service. So with Locksmith you can have reboot strategies for the automatic updates. So if there's an update and all the machines download the update and start the reboot, it's very bad because all the machines are going down. So they're communicating, like writing to etcd, doing a distributed lock. I'm going down now, no other machine is going down now, and if the machine is restarted, then the other machine maybe starts to rebooting. So that's what Locksmith is for, and Cloud Config is a configuration to initialize your cluster. You can add configuration to a cluster starting on AWS via Cloud Config. I'll give you some more examples. So first, etcd. Etcd is built on a rough consensus algorithm, which is actually, to make it simple, if you have 5 machines and 2 machines are going down, 3 machines are still working. If 3 machines go down, nothing is working, because you need the majority of the cluster. And this is because in the CAP theorem you have availability, network partition tolerance, and consistency. And etcd is on the side of network partition tolerance and consistency, because you need consistency. You don't want to have split brain situations in your cluster. Because if you allow writes to come in to the 2 nodes that are not the majority, and you also allow writes on the 3 nodes, then you have like conflicts, and you need to resolve them, and you don't want to have that in your cluster. And this is the simple version of it. Actually, there's quite a nice GitHub page of the rough consensus algorithm. There's lots of videos and tutorials and stuff like that. You should look at it. It's really nice. And yeah, of course, it has a REST interface. And of course. And to build your etcd cluster, you need the discovery API. It's open source. You can run your own discovery service. That's the official CoreOS discovery service. You just curl it. You get another URL, and this URL you give to the cluster, and all the peers of the cluster are asking the URL for the other peers. So the peer says, hello, I'm a peer. Give me the list of the other peers of this cluster. This is just for discovery of the nodes within the cluster. Cloud Config. So actually, that's what I already said. So what you configure is mostly the CoreOS tools, but also users, or you can write some files, and you can initialize systemd units that you want to run on the server on, like, right from the beginning. And this is a simple example. So you have it's a YAML file. You have the CoreOS etcd, and then you give it the discovery URL and maybe the address of the etcd node, the etcd peer, and so this is how it looks, and it's very simple. Yeah, I already said that. So Fleet is a very simple scheduler at the moment. So if you look at other schedulers like Mesos or the Google Omega paper, what they are doing in their data centers with scheduling, it's very simple at the moment. Actually, it doesn't know about resources at the moment. They're working on that feature, so it doesn't know how many memories left in the cluster, for instance. But they're heavily working on that. I think the most important thing what Fleet does at the moment is it resolves service dependencies. So if you want to run multiple services and one service has to start before the other service, like a simple setup with a 3-tier web app, it's like your database, you have application and maybe your load balancer in front. Then you want the database to start first, then your application, and then the load balancer. And Fleet resolves that dependencies for you, distributed over the machines. And I think none of the other scheduler does that, because they're always looking at like something like batch jobs or services that should run, but they're not resolving the dependencies. And I think that's where Fleet shines at the moment, and that's really interesting. And yeah. So with Fleet, you give a unit file, which is exactly what you would use locally on your machine if you have systemd. So this is a Redis server, and with the environment file, etc environment, you get the public and private IP addresses of the CoreOS node, because you don't know them, and maybe you need them, like here for the port binding. So this CoreOS private IPv4 is coming from etc environment, and that's very handy if you're on Amazon, for instance. And then I just define the image. You don't need to do that. You can, because I'm using it twice. Like there's the Docker pull image, and then it's the Docker run image, and so I define it as an environment variable over there. And actually, it's just doing the exec start pre first to pull the Docker image, and it's very important because at the moment you're starting the Docker client within the within systemd, and that's not the actual container. And if the client first starts the Docker pull, systemd thinks, okay, your service is running, and Docker doesn't communicate that to systemd correctly. So you have to do the Docker pull first, and then the Docker run to be kind of sure that your container is running. Because otherwise it's the dependency resolution of your services will just not work, because Fleet gets the status from systemd, and if systemd thinks that your service is running, then Fleet starts the other service on other nodes, and the database is actually just pulling and not running. So that's very important. Yeah, this is starting a service. So you use fleetctl. You have a local file called redis.service. You start it, and starting is actually submitting this file to the cluster, then loading it on a node, and then starting it. Then you can list your units. You can have a status which is similar to the systemd status, and you can have the journal, the logs of the container. Of course, you have to write your logs to system out, to see the logs. And you can, of course, stop and destroy those services. So, yeah, this is how it looks. The picture is not really right, because you have etcd running on each of the node, and it's not a separate node. But Fleet takes care to put your load balancer of a random machine, kind of, and your app container and your database. But in this situation, your app container is actually talking directly to etcd, and your load balancer is talking to etcd directly. And maybe you don't want to do this. So there's a concept called sidekick containers, and you can run a separate, a second container, and you can tell Fleet that this container has to run on the same machine like the other container, in this case the database. So this container watches the other container by a Docker link to that container and writes this information to etcd. So you don't have to modify the MySQL image from the Docker hub that it writes to etcd, because you don't want to do that. You want to use the Docker hub images right away without changing. And that's why there's a Sidekick container. And the same thing, you can do the same thing on the app container side, because you don't want the app to talk to etcd directly. So you have an ambassador that is started on the same machine and before the app is started. And it's a TCP reverse proxy that reads the information from etcd, where the database is. There can even be multiple backends of the database if you like. And the app is linked to the ambassador. And the app thinks, okay, that's where my database is, but actually the ambassador is redirecting your packages to the right instance. So you don't have to talk to etcd directly. Yeah, for me, CoreOS is quite powerful and very promising. Lots of small tools, not a very big building block like Mesos, or so I'm quite interested in what's happening next. And maybe if you come to Germany for a meetup in October, on 14th of October, the CTO of CoreOS is actually coming to Cologne, and we do a meetup there. So if you like, come over to Cologne. Yeah, thanks for listening.
Yeah.
Questions? No?
Do you know if there are any plans from CoreOS to fix the requirement to pull Docker images manually before starting them?
I don't know exactly. There are some people talking about that on the mailing list. There's an issue in Docker for quite a while right now. Actually, I wrote my own container system that doesn't have a problem with that, just for fun on a weekend. But it's nice. It's really nice if it integrates very well. And actually, I can start CoreOS in CoreOS with that. So it's nice for development too. I can start CoreOS cluster in containers on my machine, and I don't have to fire up Vagrant instances. That's nice. But no, I don't know the official plans on that. No. What we're building with Giant Swarm. We're trying to build a product for developers to help with orchestrating microservices and to have like a really simple setup, but also a flexible one where you can, if you start easy, if you deploy your services and then you have special use cases where the platform doesn't fit anymore, usually you have to hop over to AWS and do it all yourself. And we're trying to find a way to start very easy, and then if you have special use cases to still do that, to replace our components that we give you in the beginning to have your setup. Yeah, so that's the plan. Okay, thank you.